So this is a CS125 project by Dirk Wallace and Amrit Singh. Our app, titled the Airplane app, is an app designed to return the required takeoff distance for a specific model of airplane upon the input of a user's carry weight in kilograms. This app takes into account current weather conditions, including pressure and temperature, and depending on the mass that is inputted as well as current weather conditions, the takeoff distance would vary. We will show the app working now, so we will enter in a certain weight and then click on a certain model of airplane, and the takeoff distance in meters is displayed below. However, there is a max carry weight, so if we input a very large amount of mass, it will show that the function does not work and that a new weight must be entered. This is because obviously there are certain masses that no airplane can fly with. Each model airplane does have its own max carry weight, obviously. So now we will go through the code and show how each part of it works.
So this is our main activity.java. Here we first need to initialize the buttons that we have created in the app view. As you can see, this is the button for the Boeing airplane, and we've got similar buttons for others, as well as a text view and a text input. Once the initialization is done, we needed to ask the user for permission to access their location data. This was important because we required the Android Location Manager to return to us the latitude and longitude of the Android phone, such that we could pass it into the JSON API and therefore get the weather data at that particular point.
We also needed permission to access the user's internet. And we did this as well because the Java API that we use also required an active internet connection. These set on click listener portions are the buttons. So for example, when the Boeing button is clicked, those set of functions execute. The same with the Blackbird and the Airbus buttons. We defined an array of a two-value array that would include both the current temperature and pressure, and we filled this array with its values during the start API call. So we requested the information from the API, and then in this onResponse method, we took the response of the API, which was a JSON string, then we parsed through the data in order to find the pressure and temperature. And as you can see there, the first element of the output data was pressure, and the second element of the output data was temperature. These two pieces of information in the array will then be passed into the specific model airplane class as in its constructor.
Moving on to the specific airplane class, we stored data that is unique to each particular model. For example, this particular model is the Boeing 777, and we have data ranging from wing area, aspect ratio, thrust, and other associated values. The data that was passed on the JSON was used to calculate the current air density, which is essential when trying to calculate the total takeoff distance. Our constructor here handles the initialization of variables such as temperature, pressure, and carry weight. This function calculates the takeoff distance by taking into account the takeoff velocity. The takeoff velocity is calculated according to a particular weight and air density, as well as some other variables. We also included a 1.25 times safety margin because that's standard in the industry. Using an approximation, we calculated the takeoff distance using some methods that we learned in physics. Unfortunately, we were unable to get our Euler integration formula to work properly. We had hoped that this would provide a more accurate solution to our problem, but the loop would not terminate and therefore our app ran out of memory, probably because of a misplaced parentheses. However, our approximation is fairly accurate because we graphed both, and the Euler integration returned a linear graph, which implies that it is very close to the true value, and our approximation is valid.
There were also other technical issues that we ran into during our time creating this app. The first major area of difficulty that we ran into was the entire portion where we found that we had to request permission from the user to both access their location as well as their internet connection. This was something that this was an issue that we never run into during the MPs, so we found ourselves very confused at first, but eventually, through the help of the CAs as well as some very pertinent information we found on sources online, such as Stack Exchange, we found that it was actually a rather simplistic solution that involved only making a few changes in the Android manifests, as well as in our main activity. And then the second area of difficulty that we ran into was actually making the API request call and then taking the response from the API request call and trying to make sure it was a string. Again, to help with the CAs, we found the solution rather quickly, that it was the response. And once we did have the string, JSON string, we found that it was actually rather simple and easy to parse through the data and find the temperature and the pressure, as that portion of our app was actually rather similar to the parsing portion in MP3. And of course, the third issue that we ran into, as we just discussed, was with our original Euler formula that we found would never terminate. So we switched turns throughout the creation of this app. Generally, one of us was actually writing the code itself, while another one was on standby on another laptop, ready to look up our problems that we ran into online to find solutions to them. And in the future, there are other ways. We believe that there are certain ways things that we could have done to improve our app.
If we had been given more time, we would have liked to achieve a slightly cleaner UI. Currently, the value of total takeoff distance is being returned as a double, which is not rounded off. As such, it looks very messy. We would have loved to add a rounding function to take care of that. We would also have liked to include more aircraft, as well as other forms of weather data, such as wind direction and wind speed, because these do affect takeoff distance very significantly, and we feel that would make the app more applicable to industry. We have to declare that the work was ours. We declare that the code in our app was completely original. We did not plagiarize from any other sources. We also would like to thank the TAs and CAs for their assistance